Cool. Right, it's posted we're live. Okay, so cool. Welcome to another stream, everyone. So last stream we were looking at this Ghost of Tsushima presentation kind of as inspiration for a sort of grass system. And I was thinking about two different ways of doing it. And then I kind of got inspired by the Ghost of Tsushima one and decided that, it could probably be made into a plant system as well. So I think over time we want to change it into a plant system and even do trees as well from this. But we obviously want to start with grass because we came at it from the point of view of grass. Now I was thinking about doing things as being doing as a bunch of 3D boxes instead of 2D like it is in Ghost of Tsushima. But thinking about it with my renderer, it would actually be very bad if we did it with a 3D box because the way our transparency system works, we'll basically use all the layers up and we might get missing pixels, if you will. So the effectively see if I can run the game. Well, we don't have anything anymore. Yeah, we used to have I got a plane there. That's where the grass is going. We'll get grass there today. But I'll get Milton up. I'll explain the issue. So effectively on the screen, you draw like a bounding box, right, like a cube or something. And I'll go like that one. Yeah. And then inside the bounding box, we'd actually ray march into it, and there'll be like some bricks or whatever, right? Now, the problem is if you miss, if the bricks are in here or whatever, but then you go through these corners and you don't hit anything, you'd actually render the layer behind, and it would have been another sort of box that would have been drawn behind this box. And you better hope you hit something in going up to about 4 layers. If not, it will just render the sky. So if we have tons of blades of grass, right? Tons of blades of grass, but say if there was a bounding box around them or whatever it was, and you just so happen to have skimmed many blades of grass, like 4 in a row, then it'll just render a sky. So this is why what we should do is for the grass blades, we should just do what Ghost of Tsushima is doing and just do a grass blade mesh. And for things like plants, the stems should probably be a mesh that's mostly opaque and we never miss. We never ray march much deeper into it. But then maybe for stuff like the petals, maybe those can be boxes. So that way we less the amount of possibly overlapping geometry. Oh, sorry, potentially empty space geometry, effectively. So that's the only thing I wanted to add to this list from last stream. But yeah, I think we should go and build out this full system. It'll be quite cool. And it will work with the material system as well that we're building. So yeah, it'll be fun. Exciting times. Right, I'm just going to start a quick prayer. Then we'll start with just getting a grass blade up and get it animating and stuff like that. I think that'd be a good place to start. Right. Father in heaven, thank you, Lord, for this day. We bless your holy name. Thank you for our lives. Thank you for the fact that we're still alive. So many people who are at our age or younger have passed away. And we've lived to this age, and we just thank you for that, Lord. Thank you for the breath in our lungs, the food on our table, our spouses, and our loved ones are just still around as well. And all those people who survive in our family who survived COVID, Lord, we thank you for that. We thank you for the warm shower we get every day, and the fact that we're not in a country that's an active war zone, like other countries are at the moment. We pray for peace in the world at the moment. You know, all those countries that are going through wars which should have ended by now. We pray for peace. I also pray that the hearts of this country, hearts of every country change and align themselves back to you, Lord God, and that they pray and seek your face and repent of their sin and turn from their wicked ways. Or we all turn from our wicked ways and we turn to you, Jesus Christ, and you shall hear us from heaven, heal our, forgive our sins and heal our land. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So, and that was scripture, by the way, is 2 Chronicles 7:14. It's a good one. If you don't know it. Yeah, so yeah, this is gonna be really cool. So we are gonna do a 2D spline. Let's change we are gonna have a stem which will be a 2D. It will either be a 2D mesh or 3D mesh or yeah, 2D or 3D mesh. Okay. Well, something like that. With many segments, right? Now, I was thinking we should do yeah, we'll do the tree thing later on as well. So the con would be the transparency. No, it won't be that anymore. We fixed, yeah, it's fine. Yep. Yeah, let's try that. Cool. All right, so. Right, so where we're going to start. So effectively, we just want to draw a blade. We probably draw multiple blades on that plane. And it will probably be nice actually if we just plug in a proper camera system. We have the orbit camera, just put the input controls in so we can move around it and take a look. But yeah, so we want to program out something like known as a grass blade. For now, we're just going to instance it on the GPU, right? Just, yeah, generate those on the GPU because it's just easier to hot reload that way as well. And there will be a vertex shader, which will read from the instance data. And then we can just tweak that. So I guess let's just start off with the camera quickly. So there is an orbit cam. Now there is a camera update, I think. Update transforms. Right, so there's this thing. Fly cam, orbit cam, right. So I've just not done the controls for the orbit cam. Now, where's this at? And we're not got it plugged in at the moment, okay? So we've got this relative mouse. Yeah, I think. Yeah. So if we look at the camera structure, what do we got? Yeah, so I think let's just plug in the mouse for now. Like, I'm not really interested in the moving it around the world type of thing. So I think we should just be able to get by with a mouse X and a mouse Y. And we're just, again, looking just to change those variables to be like camera, camera, orbit, phi data. So I think data is your x. So we'll just do plus equal whatever the relative x is, yeah? And then now the problem is like you don't want to allow it to go too high because it might flip or something like that, but we can just see how that goes. We also want a way to be able to stop the update. If you press like the escape key or something. So we've got to capture that as well. So, right, so where's this? It's in the update somewhere. So I reckon we can just throw it in here somewhere. So camera transforms. So I think we chuck it in there. So the packet. So the OS packet is like the input. It just has, it is a structure filled with everything that the operating system reads that could be useful. So like all the input that's happened this frame and what state it is in, you know, where the windows are, what size are they, that sort of thing. So we can read it across any thread. That's the idea. So G game world camera in some kind of delta time, which I would have thought we would have had, mind you, but there we go. Right, so there's this guy, right? So I think we should be really having a proper delta time in the game. I'm not sure what's going on there. It's not too difficult to do it. So let's do it. Where do we stick the delta time? Probably here. So in G game. Game.h. Float 32 dt. Yeah, you stick it globally so you don't have to pass it around like every function. Pretty good. So game dt. So frame start. Oh, we need to store a frame and OS time for the frame start as well. Okay. There we go. Lovely. So delta time needs to be passed into here now. G game. Right, so that should do the update. Come on, machine, tell me if that's right. Oh, it's in the world structure. Whoops. Where's the game structure at then? Game internal or something? I guess it's in here. I don't usually put structures inside C files. But there we go. Alright, we'll live with that for now. Okay, so we should be getting some kind of rotation now. Oh, interesting. Lovely. So it's obviously like stupidly fast, but it obviously kind of works. So that's good to know. We also want a way of like trapping the mouse and stopping it from updating. So we find, right, so look speed. All times look speed times DT, of course. Yes, I think you want something like this. All right, here we go. So it's kind of going the wrong way. And it's not going up and down. It's strange. So that's interesting. Oh, that's because we've got it fixed. It keeps saying every frame, that's why. Right, so we need to actually do a minus for some reason, but anyway, that's just the way it works. So, yes. Now, where are we going to? There's, yeah, it's hard-coded here, you see? Uh, that's not really right, is it? Maybe. No, 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 no. The whole point of the orbit cam is that the fire just controls. They should be orbiting around a point, and the fire just controls how high up you are. So why? Oh, because the distance is one away. That's why. So if we make it like 6 away, and then that plane that we're drawing, that plane, yep, we should draw it on 0, 0 where it's actually looking at. And then that should work how we expect. There we go. Lovely. So we probably want to have a zoom. Right, so if we turn it to the right, the whole stage moves, turn it up. Yeah, that's good. Okay, cool. Right, so now we probably just need an escape key to stop it from actually moving. So there used to be a thing in the OS called like trap mouse or something, or look for the mouse. Virtual mouse. Show hide. I don't know if that's implemented on Windows. Hang on. No, it's not implemented yet. We could do it. I know it's worth it though. What we mainly want is an update, I think. So all we're looking for is basically something to do with the camera update or whatever it is. Like, do you just disable it or something like that, or do you have a disable on the camera to disable the input, or yeah? So right now, yeah, I guess it just doesn't really matter how it's done. So for now, I'll just say, update camera. Right, so we press the escape key, just find that. So if the escape key has been pressed, the input packet, isn't it? So somewhere here, right? So if ggame dot update camera, then update the input, yeah? Now, if ggame.world.os packet, now we're looking for like the keyboard, right? If you've pressed, it's a virtual keyboard. If you have OS virtual keyboard, has pressed, virtual key code has pressed. I guess so. So that would be OS key code escape. Now we just toggle this guy. So or equal 1, yeah? Sorry, XOR. Lovely. So that should allow us to at least... Oh. Ah, yeah, so it started as off. But yeah, I can press it and it... Amazing. So we do actually want to zoom. So we want to do a mouse wheel. And then we can start by putting a grass blade down. Get that procedure generated, which would be cool. So where are we going exactly? So I'd like the camera zoom. Yeah, the fly cam is interesting. We could get that back. Yeah, I like the orbit cam for now. So yeah, we want to do like if the wheel, the Y, if that's moved, then we want to change the distance. So yeah, let's call that. I don't think it needs to be times by dt. So it's 1. They'll give you a value of 1 or minus 1. Then 1 or minus 1. So yeah, I think that'd be fine. So where's the distance? Nice. Now we want to make sure we start off the game at, let's just throw in here somewhere. Ggame, put it as ggame, update camera equal true. That'll do for now, yeah? Cool, so it should just start off. Right, start off a bit flat, but I guess it's okay. Phi should already be started off at least 45, whatever it was. So phi 35, yeah, so oh, that distance needs to start at 4 then. Amazing. Cool, so now we've got the camera in a good place. We can now move on to getting a grass blade. There you go, so you can sort of move that around, you can zoom. Hang on. Something's weird. He zoomed in, but not out. There we go. So DH. So mouse wheel Y, distance plus equal this, right? That's a bit weird. So just print that out quick. What is going on there? So it's is that an int, right? Is that what it is? Yeah. And this would be a float. So what's your problem? What's going on? Oh, okay. Right, it wasn't. So if I use the mouse wheel and move the mouse, it was updating it by the movement of the mouse rather than the actual wheel. It's the other way around, but that's good. Reasonable enough. Maybe we can divide it by 0.25 or something. Go in quarter steps, which would be cool. Amazing. Right, so now let's get some grass going. Yeah, so I can use my mouse wheel up to go in. Amazing. Yeah, then you see it is clipping a bit, but that's fine. All right, beautiful, beautiful. What distance is that? We should probably get like that kind of close, maybe. Okay, so we're gonna basically do it the way Ghost of Tsushima is in terms, not necessarily the placement of where they go. We might do it with like we might do that in the end with like a texture for the landscape. But we're obviously just gonna want to be rendering the grass blades first. So we'll probably just do a very similar system. So we'll have but yeah, in the future we're gonna expand it for like plants and stuff as well, and probably trees, which would be cool. So let's just start simple. Start simple first. So on the GPU, we're going to be spawning grass blade instances. Those just go into into a global buffer somewhere, appended on, and then we have an indirect draw, which will basically dispatch a high LOD grass blade or a low LOD grass blade. But we don't have to care about the low LOD just yet. We could just do the high LOD for now, and we'll distribute them. So we'll just do them on a grid, and then we can do maybe we can do like a 3x3. We can have them being quite, or we'll do a 4x4, have them being quite big so we can see them. And we'll have configurable parameters and stuff like this that will just gradually build in. And we'll try and get them to procedurally animate and bend over and stuff like that. Maybe we'll make the grid bigger as well. But yeah, maybe those will be parameters that we can configure. But that's the basic idea. Yeah, so, okay. So where do we start? So we probably need the vertex shader and yeah, I think let's just start with the structures, right? Start with the data. So graphics VK shared. We're gonna have, let's find the, graphics VK shared encoder file. So this will allow us to create packed structures from the get-go and make them configurable. So we basically want a grass blade instance. probably. So grass blade instance GPE. So they probably want a position in the world. Position in the world, in world space. They probably would like some kind of rotation along the y-axis, right? So that could just be a float 32 to some degree. No pun intended. Then, so position world space, then rotation. Around the y-axis. And then they'll obviously bend in that direction as well. Then, what else do we need? They would obviously want a material, but they're not packing. Yeah. And they would just use the same mesh pixel shader, I think, where they just put the instance index and all of that basically into the layer buffer. So then in the scene shade, we can fetch the grass blade. So we'll probably have a high bit or a couple of high bits which determine what type the pixel is, like a pixel type. Or like an object type, basically. So you can have a mesh object type. You can also have a grass blade object type, if you will. And yeah, so they also had a way to make it such that you can define how high up these things go. So it's just a triangle strip, right? I'm pretty sure. So you go doom, 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 and then it will do the rest, right? Sorry, it's there, 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 there. So you can just predefine this triangle strip. I think that should just do it. And then effectively they probably just had 16. Sorry, so it's 15. It's 1, 2, 3, 4, 5, 6. Yeah, so they just define how big is that. So 1, 2. Yeah, so there'll be it needs 6 at most 6 signed, very unsigned norm values. So effectively, it would just be all packed into like, 6 times. How many do you need? You might be able to get away with 6 bytes of it, basically. Just 1 byte for each. But yeah, so you probably would do. Hmm. No, it doesn't have to be a full. Yeah, I wonder how many. So if you got 32-bit in, how many can you fit in? 5.3. So that would be. Six each, right? So 6 is. Hang on. Yeah, it would be 16, wouldn't it? No, 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 no. 4 is 16. One shift left 4 is 16. 5. 5 is 32, 6 is 64. So that would be 60. Yeah, I think that's plenty of precision that you can use. So yeah, you could pack it all in. This would be what's known as the lengths, the segment lengths. And it's just bit packed. 5 bits. Hang on. 6 bits. No. So how many segments was there in the end? 1, 2, 3, 4, 5, 6. Yeah, so it's 32 divided by 6. That fits 5 times, doesn't it? 5.7 times is 6 bit. No. Yes, it'll be 5 bits each, so that might be enough precision still. Yeah, it should be. So that'll be 30, value 32, right? 32 different steps. You could probably go up to, yeah, so like 5 bits each segment. So there'll probably be some kind of segment grass blade segments capacity. So there'll be 6 different segments. Then we'll probably just do So you only need to use 30 bits, so we've got 2 more bits for something else if need be. Be explicit about that for now. So we'll just say unused. Then we'll also need a material as well. Very nice. So what else about these segment lengths? They probably would want to have a maximum size of a half, maybe. So the maximum size would be, so 5 bits remap into 0 to 0.5 range. Hey there, Davros. Grass incoming, exactly. Yeah, so it's going to be a grass system to start off with. We'll evolve it into a plant system, and then probably for it to support trees as well. Yeah, we're just starting off with grass right now. The reason why we branched out into grass is wanted to add more materials, and then I was thinking about, we should just add grass, and then it sort of went into, because we did a moss one in a previous stream, basically got that working. It looked kind of alright. What can I show you? I can show you that one. I took a photo. Yeah, so it looks alright. It's not. It's just a first pass of moss. When you get in there, you can really see it's not really anything special, but it's just 2 colors, and so it's just 3 spheres that are then smooth union together as SDFs, and then a value noise is applied on top, and we just remarch into that, and it's just a cube around it. So these are things which could be decorated on top of other materials. So I was thinking about just doing grass next because I already done moss, and now it's evolved into just doing a grass system. Because, yeah, we're going to need some kind of easy way to put down grass and plants and stuff like that. So I want to make sure that the material system works with these sorts of things, basically. That's the idea. I think after this one, we'll do probably some kind of terrain, right? We'll probably just do a height map. I'm not sure though. We'll see. But then that way we can fit the grass on there and, do a tree or whatever, right? And this is before I'm really doing a proper mesh system as well. It's all a bit weird, but I'm trying to make sure that this kind of procedural material system works well first before I do anything to do with like meshes and then sorting those things out. Yeah, making sure the whole order independent transparency system works with different things as well, So, but yeah, we should be able to gauge some kind of performance as well in ways when we get some of this stuff going, which would be cool. But yeah, so yeah, it's gonna be nice. How's things been with you? Yeah, so I think this model's kind of what they do over at Ghost of Tsushima. So this is probably a good place to start. I think there was maybe a bendiness as well, maybe. I'm not sure. But it's a good place to start. So we just want to have arrays of this. And we probably would just only populate them on the GPU, but obviously it'll be possible to extend it to be CPU side as well if we wanted. So we just need to go into the shared, here we go. We need to define a descriptor buffer ID, grass blade instance GPU. There we go. Now, this is where the fun begins. So we want to make our shaders now. Let's go to the shaders folder. I've got that bookmark now, so I don't have to traverse through my hierarchy of folders. So we want to take a compute shader. So let's just take where's a simple one? Let's take draw 3D. Oh no. Bloom up sample. I think that'll be easy enough. So we want to have a grass emit. Or we could call it plants emit. Let's just call it grass emit. I don't know. Let's keep it specialized for now. So it just emits grass. The next thing we would like is so with a mesh, how does that mesh render LB fragment shader? So we just need to have, oh yeah, because it does kind of depend on those push constants, doesn't it? Yeah. It's interesting. What does that push constant structure look like? It has an instance ref come in. So I think we can make this reusable. Mesh instances, right? And the vertices. Well, maybe we can use that one anyway. But for grass. Just throw a grass buffer in there as well. But yeah. Then have a different vertex shader. Because then we can reuse the fragment shader. I'm not sure. It just probably doesn't really matter that much, but yeah, it's basically reusable, right? So might as well. Yeah, let's do it. So we'll call it grass render LB. Lovely. Isn't that nice? So build system needs to have a few things there, so we just have a grass spawn. Grass emit, rather. Then we need a grass render layer buffer. So that will be a vertex shader. Then we go to the graphics VK side of things. We find where we've done some kind of compute. So I think draw 3D setup will take me there. Define the compute pipeline. Grass emit. Then we want to define what's known as a grass render layer buffer. Okay. So let's go ahead and find the mesh render layer buffer and make a new pipeline. Thankfully, it's not too difficult. Yeah, we basically don't need any... Hang on a minute. Why is there a depth test as true when we don't really need any... We don't even pass in any depth attachments or anything. Cool. Anyway. Lovely. Now we're going to be using triangle strip for sure, because we want to... Because it's just easier, right? Then... No primitive restart, we'll just use instancing. We need no culling. We need no comparison. And no attachments, because it's all done manually in the pixel shader using that, you know, pixel interlocked thing. Right, we manually write into an image texture because we do layering. Now, grass and voila. So we want to find where it's in the mesh render. Render meshes, right? We simply just want to copy this and grass, make it grassy. So render grass. So grass. Now, this push constants thing is interesting. We could just put a thing called grass instances on there. That might be the best thing to do. Rather than changing its name, I think it's best. But when we have the plant system done, then maybe we can change its name. I don't know, and maybe there'll be different material, different render types which go into that sort of layer buffer. There'll be like a pixel type, that sort of thing. So, where it allows you to extract out the materials and stuff like that from it inside the scene shading pass. So grass. All right, so I think then. All right, so grass, lead, instance, GPU. So grass instances. And, you know, it doesn't matter. We have up to like, you know, 16 different slots on here basically, because it goes up to 64 bytes. So we can just keep adding these until it becomes a problem. Then we'll just probably share some fields, but it'll be fine. So we don't have to fill everything in there. Right, so this would be grass instances. Now, we're going to want something probably called a plant cache or something like that. That'd be fun. The cache of plants. And with the cache of plants, we can have a grass. Plant cache. Grass instances buffer. We sort of make that thing, but it's cool. Here's our two output buffers. There's an object layer and a depth layer image. So it's 4 layers. Each channel is a layer. All it's doing. And it's sorted front to back. Now, so this is basically for order independent transparency, that sort of thing. Yeah. So get rid of those and voila. Nice. So let's go ahead and make, quickly put together the plant system. It's not going to be anything particularly complicated like the other ones have been. The other one's been a bit more involved, but this is going to be more GPU driven, so there should be less CPU side code. But as time goes on, this will grow and be more complicated because we'll have different types of plants and all types of data paths from the CPU. But for now, this will be fine. So this will be called a plant cache. So grass instances buffer, and that'll do for now. Lovely. So underneath the mesh system, essentially, just gonna put this guy in here, and we're just going to tell it to initialize the buffer. So we're going to go to the way these constants are declared when it eventually gets us there. That'd be a plant cache grass blade instances. So the grass blade instances, let's just say there's, 1,000 isn't really enough, is it really? But sure, is it 1 million? Right, 1 million ought to be enough. Put it that way. So graphics VK grass blade instance GPU. Oh, where did that go? Right, so grass instances. Here we go. Now we should really call it, to keep with what we have, we should really call it grass blade. Come on, work with me. Not sure what's up with my hands today. They do not want to work. Right, so is that grass blade, render grass. So we need to make sure we call these functions from the... Oh, we go. So we need to make sure actually you call these render functions and the initializers in the right place. So the render happens after the meshes. They could probably happen at the same time. Yeah, we could probably in the future make them overlap, but for now, won't worry about that one. So we also need to initialize. So we initialize the mesh cache we want to make it also initialize the plant cache. So that should create us. Yeah, all we need to do now is run the emit meshes code, right? So this is going to be great. So where's the render? Here we go. So we're going to do a grass emit. It's just going to take in the grass blades. They'll be read write. Maybe write only, but whatever. Now, yeah, write only. Now, we also want to make sure that we kind of know. So I think in the global structure, we want to store maybe like an atomic index that we can sort of like, you know, bump up. Yeah, because this is where these ones are, the draw words and that. Does GLSL have a line as? Because in my shading language used to have made it have a line as. It was cool. Because I can make it align to a cache line. You have to manually put the padding in. Great. Fun. But yeah, no worries. So grass blade count number of instances. Oh, that means we need another. So after emit, we actually need to have a setup. Yes, you have a mesh. Hang on a minute, or is it mesh render? No, mesh is done from the CPU. Yes, you need a grass render setup. Which will basically just copy the indirect arguments. So I forgot about that as well. We need to make it indirect. But it's alright, we'll get there. So, right, so where's the indirect args? They're here. So we need grass. Right, it's just grass. Grass render, let's call it. Lovely. Well, then shouldn't this be called draw 2D render, or let's just call it grass? No, we'll leave it there. Cool. Now, right. So the next step is in the frame initialize. Do we even have a frame in it? It's on the GPU. That kind of sucks. Do we have any kind of frame start thing? Right, so I think we need a graphics frame start then, not GPU, because GPU is the sort of lower levels. You know, it's just the abstraction of a Vulkan, basically. Yeah, so we need another one of these. How annoying. Right, another computer shader. Ah. Yeah. Alright. So it's fine for all these render. Yeah. These are where our pipelines are at. So we want a render setup. We also want. Oh yeah, Init is different, I think. Don't do this to me. Yeah, no, I think that, yeah, this is init is like just initialize when you initialize the system. We want frame in it. Yeah. For initializing the frame. Now, right. So those do need to go off in the build system. Let's just quickly chuck that in. So that would be grass render setup and frame in it. Cool. So frame in it. All it's gonna do. So it's just a one thread thing. It's just going to target the global. So just do G. So inside globals there's a thing called. Hang on a minute. Wait a minute. When do those draws and everything get cleared back to 0? Like the draw 3D. Oh yeah. So yeah, when do these get reset back to 0? Oh no, they get uploaded to. Right, that's a good catch because yeah. So this grass blades, I guess it can get uploaded. And that way it's cleared to 0, but everything after this point is not uploaded, so it just stays persistent in memory inside a global buffer. Now, yeah, because we might want to have, you know what, let's put it afterwards because we don't really know how we're going to be placing them. Yeah, for now, let's just set it to 0. Alright, cool. So there's our thing there. So we just go into the shared header file. We find, alright. Oh, GPVK, there we go. No push constants. Nice. So we want to make sure we are syncing on the global. So, oh, this needs to happen after. So the upload needs to go in, and then I need a frame in it. Right, hang on a minute, guys. Okay, so we need to sync on the global buffer. Read write. Nice. Right, what is next? And so now in the grass system. Oh, so to render the grass, we actually want to be doing a draw indirect. Yeah, draw indirect, so it's kind of a bit of a different thing. Let's find one of these. We can get some of the parameters. So we want something like this. So it's going to be using grass render. And these two parameters will come from a structure on the GPU. So how we populate that, get that structure going, is we need to make sure we call the setup code. So it's like one of these. These will be reading the globals, so why aren't they doing a read only on the global buffer? Yeah, hang on a minute. These guys need to be doing a read only on the global buffer. Because draw 3D setup. Yeah, reads from the global buffer, you see. That could have been a big problem. Right, so we're going to take one of these guys. We'll go back to the grass side of things. And so before we do kick off the rendering, which uses the indirect args buffer, and we'll read from this grass render offset, or read from the grass render indirect args at that offset. We need to call grass render setup. Now, grass render setup. So I've got like a little macro called I, which just accesses that indirect args buffer. There's only one because I don't feel like I need more than one. So it allows my GPU API to be a lot more simple and I don't have to pass in these extra flags everywhere. So I'm hoping I want to change that in the future, but for now, it's serving us well. So grass render. So how many vertices? That's a good point. Well, if we're going to be doing the Ghost of Tsushima one, we need 1, 2, 3, 4, 5, 6. Well, he says 15. Let's just double check I got mine right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow. Incredible. So it is 15. Instances, well, we'll get that from the grasses. Grass blades count. And then the offset's are 0. Yeah. Lovely. Lovely. Hey, Sully. Welcome, sir. I don't think so. I think my GPU will be alright. It's just a mid-tier, though. You know, it's RX 7600. Yeah. So it's like a 3060. Yeah, it's alright. That does the job. It can't have anything too good, you know? It'll be fine. It'll be fine, right? Right, Sully? Cool. So I think that's everything, right? What could go wrong? Right? What could go wrong? So we're not going to be rendering any... Oh, okay. This is what can go wrong. Grass emit is doing something completely dumb. That's what it's doing. So we need grass emit to be doing something right. Okay, so if we just emit an 8x8 grid of grass blades into the grass instances buffer, and that might be what we need. I don't think we need to care about the swizzle thing. Maybe we do. Yeah, let's just keep it naturally swizzling. Whatever, naturally swizzling. So, yeah, we'll just do GPU shared. Right, where's my grass? Oh, I've already got it here. Yes, it's got the instances coming in. They're right only, that's for sure. And yeah, I think we'll control... No, we need to control it from the CPU side anyway. Yeah, so we'll do a... Nah, we'll just do all 8x8, okay? Nice. So push constants, grass instances. You do like a buffer read write only, sorry. Of that. Index dst coordinate dot y times 8 plus dst coordinate dot x. Then simply store in there your grass blade instance. So graphics vk grass blade instance. Yeah, we also need to write the vertex shader. That's the thing we're missing. So instance is equal to whatever this thing here is. Then we need to do some atomic add. That is a thing, right? G. So this needs to sync on the globals. So that would be. Where's the emit? Oh, we're not even running the emit shader yet. Grass emit. Read write. Grass emit. I think that's right. So 8 by 8 by 1. Then we need to be filling pc.grass instances with this. Right only though. Nice. Lovely. Alright, what else was we missing? Yes, the vertex shader needs to be done, but let's get back to the grass emit. Finish that one off first. So yeah, we've done the globals sync as well. So the globals should, yeah, it's rewrite. So that would be grass blades count increment by 1. Nice. You could optimize that in some way, right? By doing wave intrinsics and stuff. But for now, let's just do this. Right. To do optimize with wave intrinsics or LDS. Yeah. Nice. So good point. We need to fill in all of these guys. Yeah, so we might need to pass up some kind of material that we just feed into all of them from the CPU side, and we can just call it a... Well, yeah. We need a special kind of material for the grass, but yeah, it could just be emits green, right? But it's very true, isn't it? Right. Let me just do a secret screen, secret thing. My notepad is not revealing anything sensitive. So yeah, let's quickly write the to-do list down because I'll forget otherwise. So I'm going to do vertex shader. We also need to change scene shade. And we need to make a quick grass material to feed in from the CPU. So that'll be from PC material. And we need to, position the grasses. Lovely. Right, just take a quick break, refill my drink and stuff, and then we'll finish that up and hopefully get something going. Right, BRB. All right, welcome back, everyone. How we doing? So, I did forget a parameter because we've got rotation and position, but not scale, right? We want configurable grass sizes to some degree, so it would actually, thinking about it, be nice just to whack on a scale. There, right? So that'd be a uniform scale, but actually, no, it would be a length. So, hang on a minute. Yeah, so I think this gets into like when we branch out the system a bit, it is actually going to probably be some kind of like um you'll define constraints for this particular kind of grass blade or whatever it is. What's the min and max bound and length and all this, and it'll play into the plant system, and then you just have one parameter which each instance declares and then shares stuff with the kind of grass it is or kind of plant stem it is. So for now, I think we could just call it length. Yeah. What do we do? For now, let's just call it, you know what, we can have scale X and scale Y. Why not? Why not? All right. You know, we'll make it to do make it a length, a single sharing, constructing the scale from the kind of grass, right? There'll be different kinds of grass, whatever you want to call it, like a grass type. I think we'll probably call it plant, but anyway, it'll be a plant stem and system or whatever. But for now, we start simple. So scale would be 0.1, maybe, and then 1. But then it makes them 1 high. Maybe make it 3 high. Maybe 3 is a bit big. Let's do 2. So rotation, we can make those. I'll just leave it there for now. Or you can kind of have the rotation be based on the location, but let's just leave it there for now. It'll be hotcode reloadable, right? Position would be so vec 3 dst coordinate dot x take away a half, I think. So it becomes -4 to +4. So y will be 0 dst coord dot y in the z component. Oh, we go, take 4. Nice. Now these segment lengths. These are a bit packed, 5 bits for each segment, how long it is. So if how long it is. So if you got 1, a length of unit length of 1 basically, and you want to say you got 6 segments. So how long are they? Right, so 16666. Okay, so we've got 32 bits. Sorry, 32. There's 5 bits. There's 32 possible values. So we did 1 divided by 32. Right, so we times it by 2. Times it by 2. Right. So, actually, we did it wrong. We actually want to have length for each segment except for the last. Which uses the rest. So that means then you've got an extra segment. So that'll be 32 divided by 5 instead, so 6 bits. Nice. Okay, so you got more precision there, which is great. So if that's the case then, 6 bits each. So we want to populate, there's a particular value we want to populate. So segment length, we're just going to make it even, right? For now. So Actually, it doesn't have to be even. But yeah, so well, length is kind of annoying because it can end up going past. So maybe we might just call it segment. Yeah, but how long is a segment basically? That's the idea. But we could say segment end, right? So you got 1, 2, 3, 4, 5, 6. And the last one always ends at 1. So then it always remaps properly. But yeah, so 6 bits, v6. How many bits? So that'd be 6. Be 30 again. Cool, 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 cool. So yes, in that case, we just want to manually change them, and we could. Yeah, it's kind of cool. Right, so segment lengths. What we're gonna do? Ends. Sorry, segment ends. We'll just make it 0. So we pack. Yeah, loader high. I think the way we do it. So we'll just say. Okay. So we shift left. 6 bits each, right? So we need to encode. So 63 would be the max value. So we just got to make it less each time, basically. That's the idea, right? So 1. Yeah, so the first one gets 63. The next one gets. So we should make it a bit uneven, right? So imagine let's put all the precision towards the tail. So if we bring it down by. So evenly bringing it down would be like 64 divided by. We've got 5 segment ends, haven't we? Sorry, 63 will be the end, but you never want it to actually touch the end. That's right. Yeah, so 1, 2, 3, 4, 5. 1 end, 2 ends, 3 ends, 4, 5, and a 6. Yeah, the last one's implied. It's the tip. So. Yeah, so it will be divided by 6. 6 cents. So 10 is what you need on average, right? So we did less than 10 initially. So we did, let's take yes, the first one, let's take 4. Then from 59, let's take 6. Now let's take let's take 7, I guess. Now let's take 8. You've only got 6 segments though. Right, let's just take a bigger number now so we'll clearly see it. So you put over yeah, we should maybe make it even at some point, but let's just see to make sure it works. So we'll do a 10. Let's do a 12. So 1 segment, 2, 3, 4, 5, 6. So we'll do a 14 or something, yeah. Cool. So that's one way we can do it. The other way would just be evenly distributed. So we'll have this as a separate thing. We can just toggle those on and off and see the difference. So an evenly done one would be, right, so 63 all the way. So it'd be broken down by tens basically. So you just go and voila, there you go. Right, so we'll put the segment ends in there. Right, so they're in a reasonable place. The next thing to do is to go now to set up a grass material quickly and then obviously pass it up from the CPU. So our grass system, I'll open up the debugger there. Sorry, our material system is done procedurally now. I guess you can call it geometry material at this point. I wouldn't really call it that. Yeah, maybe you can say you have no geometry and it's just no, but the blend materials that we want to do in the future. Well, man, I'm glad I've written that down because I'm on a detour now. Those will need to be done using that hash grid thing. Right. So, yeah, I think we'll just call it a geometry material. It's really dumb though. Yeah, we will call it that. Right, so let's copy the brick. We're just going to call this grass blade. It's not... Anyway. So you probably want to have 2 colors, right? What's the bottom color and the top color? Essentially. Be a smooth, and be some kind of interpolation between that. We then would like to also have a color that goes down the middle, like a seam. What do you call that? Like a, do you call it a seam? Do you call it a grass blade? Something goes down the middle. I forgot the guy called. I think he calls it something in the video, but yeah, it's like he calls it a. Name of that. Yeah, it's in this bit. So they round it as well. Which is kind of cool. Here we go. The vein. That's the name. Yeah, so just do something like that for now. Maybe there'd be like a roundness or something that we could do, like to sort out the normal. Now, how round do you want this thing to be? Yeah, for now. That'd be fine. So, what is the brick? So, grass blade. This is the Great Britain. Right, so I gotta do this now. Hex to. Sorry. Right, so P, BG, MP backwards, right? Right, so 40, 50, good, good, good. That's right. So 40, 47. Nice. So where else do we do brick? Right, so graphics. Yeah, I wonder, do we do anything with that? Yeah, it'll be in the build. The build script definitely needs something. So graphics.c. So it runs the generated thing. It would be cool if I could make this less fiddly to add a new material type. It's a bit much at the moment, but we'll see. Maybe, yeah. I think once we've got a few systems using it and I've written a few materials, I can then sort of iron out the process of adding a new one. But yeah, so in the shared header file as well. Graphics VK, I think. What is that Surge plugin? It comes built into Helix, all this stuff. This is not Vim, by the way. Do you think I was using NeoVim or whatever people use these days? So the best thing about Helix is, I think we spoke about this in the past, right? Is the config, right? Get this. The config file is a config file, right? It is not a programming language. It's just genius. You know, I don't have to learn Lisp or Vim script. Yeah. No, Helix, honestly, man. Like, Vim and NeoVim, it's just so, I don't want to use that word because it's overused, but it's kind of, for NeoVim, just, it's like the C++. Like, they take something that was like, fine, and just add so much stuff to it. But what really needed to happen is for Vim is it just needed to be a whole new editor, and that's what Helix does. It does it well. I do have one gripe with it, but I'm fine. I'm fine with it. But the one problem that I have is like I would prefer if they had a dumb, stupid string suggestion string IntelliSense where it literally just cataloged all the strings across the project, and then when I started typing it would just show me those. So when I get a broken LSP state, because my syntax is broken or whatever, so the whole thing just falls apart, or I'm inside some, you know LSPs are too smart and I just want something dumb, right? A string a string table that it searches or a string database that it searches, that thing would be amazing. So, you know, C is really it's parsing C and everything that it breaks every 2 minutes. So it's just good just to have something dumb and simple, I think. But other than that, it's really great. You know, they do gonna find a command, you press space, press question mark, and bam, you can, if you guess the words right, find where commands you want and test them out. So, cool. You should switch. It's worth it. I promise. There was a time where I was building my own little text editor because I was like, Vim. But then you know how it goes with side projects. I just parked it after a while, went on someone else. But this really does is kind of mostly what I was wanting to do. Yeah, Helix is awesome. Right, so we need to like grass board. Right, moss. Right, let's find this. Ooh. So thankfully we don't have to do any ray marching into it anymore. We could do, right? But here we go. So let's look for moss. The grass blade. So instead of textures, we just do it with code. So is there any distance? No. We just shade, right? What's the ray march do? Nothing. Absolutely nothing. Bum, 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 bum. Your T is 0, right? We've got 0 T, just biscuits. Normal. In material space. It'd be along the Z, wouldn't it? So it'd be pointing towards you. So 0, 0, minus 1. Or just positive 1. Which way will it be? It can be positive 1. So yeah, we can make it, we can kind of sort of like make that bent normal kind of thing, which would be in that rounded normal. That'd be kind of cool. Yeah, you know, I want that. I want it. I want it. So we can call it like a normal curviness. Is that you spell curviness? I think so. So really we can just go with 8 bits. Which means we've got 24 unused bits. 0 to 1, please. Gotta have some curviness. So we could just call it curviness. Love me some curviness. Now, so how could we do this, right? So you obviously need to like decode the thing. So you need to fill in all the words and all that. Grass blade. Now taking a look at the grass blade, you got 1 word, 2, 3, 4. 4 words, right? So it would be grass. Sorry, bottom, color 0, a. Sorry. Right, bottom color, top color, vein color, and then a sort of a bit filled 0. Lovely. Now, we don't need all of those here, we just need the bit filled. And then we can extract out the... But this is the shade. So grass blade. So this will be known as V0 grass blade. Material blade. Material curviness. And he's passing M, and I'll decode it to the curviness. Now, with this 0 to 1, so effectively, we can just nudge it left and right, you know, so by 1, and then normalize it. So yeah, I reckon we just do. Yeah, this is gonna be cool. So 0 means in the middle, so you basically do plus vec3 curviness. Hang on a minute. Yeah, curviness times 2 take 1, so that maps it to -1 to 1. Then there's no, sorry. You want it to be multiplied by curviness. Now the x needs to be something. What does it need to be? So you've got your UV, your ray origin material space. You've got that. Yeah, it's in material space at this point. Yeah. So it'd be ray origin. This is the UV effectively, right? Material space X. Right, that'll be -1 to 1, I think. Yeah, we've got to get those texture coordinates as well correct. That is very true. But yeah, -1 to 1. And then curviness will basically just control how much of that it's going to use. And then you just normalize it. Bam. Cool. So grass blade color. So it's a non-metal. Oh, we need a glossiness. How glossy do you want it? That's another one. Yeah, we should really call it glossiness because gloss is just boring. Right, it's no fun. So, glossiness. Now, we want to find out the color. So, the color is going to be lerped between, so we need to unpack color 1010. Or is it 1111? No, let's unpack. RGBA, this one. The HDR color. So, bottom color. Top color. based on where the shading uv.y is. So that'd be -1 to 1. So you want to remap it to 0 to 1. And then, so you need to sort out the vein, right? So now you basically want to get the vein in there. So what'd you do there? It says based on the y, right? How close is it to the y at that point? I think is the idea, right? So yeah, you probably want like a vein thickness as well. Actually thinking about it, how thick is the vein? The veininess. Ah, this is great. So you need some veininess. Man, I love naming things. It's amazing. Right, so with the veininess, if your veininess is 1, it covers the whole width of the grass blade. Right, if it's 0, it obviously is nothing. So the final thing is color equals lerp. Unpack this thing. The vein color. So you want to take the shading UV, and color. So now easy to define which way to go. So shading UV dot X, that's the one we're going to be using. So if it's 0, the yes, I think if we do ABS, yeah, so it's mirrored, basically, right? So 1 will mean it's at the edge, and 0 means it's in the middle. So we did divide by 0, divide by the veininess. So if the veininess is 0.5, it means anything which is from 0 to 0.5 will be vein. Hang on a minute. That'll get you 1. No, that's not right, is it? Yeah, so as soon as this will be 0.5, that will get you, divide by veininess will get you 1. And yeah, no, that would be right. You just got to clamp it at that point. Yeah, sorry, but that's the problem is that's gonna be smooth. Yeah, so we don't really want to lerp, but you do kind of want like a smooth step. I think that's what you want. You want a smooth step with an edge. Always forget what way the edge is. Smooth step. Yeah. So that's right, I think. So this is where the edge is, and it does it smoothly. Or it's just a step. Anyway, let's try that out. So that'd be your final color. Your glossiness goes in here. Then your AO is just 1 for now, okay? Right, so now you just need to plug in these guys. So there will be a remarch section where it is obviously not going to do any remarching. Oh, I completely forgot about this one. Anyway, grass blade. We'll add that. Cool. Do another one. Grass bold. Grass blade. Right, so we're done now on here. So now we just got to go around and got to add another type. There's so much boilerplate. You know, we should really try and code gen as much of this as we can. But until the day we do that, we shall live like this. So you know, maybe we can make some other files which just all get code genned into something. Like a material gen thing. Yeah, it'd be good if we can just use one system. That's why anyways. Alright, we keep going. We keep moving. Oh yeah. Right, we do actually need to make a new materials one, pass that up. So that's what the other thing on the checklist was. So, you know, make the grass material, we've done that. Now we need to actually initialize one and pass it from the CPU. So let's call this the grass blade material ID. So it'd just be a lovely grass blade. One of them. Nice. Now we need to actually upload. So here's me just making one. Now we're just gonna do something like this. So we need to initialize all those properties that we got. So before we do that, let's quickly move over to the grass emit and plug that in. So material. Didn't I do that yet? No, I haven't done it yet. Right. Graphics, material. Oh. That's the one I want. So, yeah, let's call it material. Do we need to somehow get that? I forget what it is now, but it's like a... Where's the mesh instance at? Mesh, cache, alloc. Got them in there, I think. Yeah, it's somewhere here. It's this code. There we go. Dun, 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 dun. So you get the material from the mesh cache. Graphics, VK, grass, blade, material, ID. Nice. So that would just be emitted to all the other grasses. You know, it's a bit of a shame you have to make different materials for each instance. If you're going to change the color and stuff, maybe you can have some variation based on some other kind of parameter passed in through the scene shading. Maybe an object ID could like be a seed. That could be interesting. But yeah. Anyway. Right, so we want the bottom color. We always want to pick like a green. Now this is in the DCI P3 color space. But yeah, so we want to do like, what's like a grass blade green. Oh, there's a Power Toys toy. Do you know this one? It's the color picker. Isn't it amazing? So Windows Shift C. Right, so all we need to do is find what we want. Is that? That's all right. Man, I wish you could just do it in my crazy weird format, but there we go. Cool. So that would be these numbers here. Yeah, there's still sRGB in it. Actually, I'm super confused. Because... Yeah, it's really good. You should try it out. Do you use Neovim? They're sempiternal, or do you use something else? It also comes built in with a bunch of themes as well. Yeah, there's so many. Ah, for crying out loud! Press the escape key. Right. Anyways, let's try that again. Oh, I'll never get that same color I had. Now, I must find the color I once had before. That'll do. Yeah, it's like a 6F or a 6C is like. Yeah, okay, so this is still sRGB, right? There should have been an S there. Anyway. Thank you. So now I gotta do some quick maths. It's gonna be a bit off because the color space is different, but I think it should be reasonably good enough. So 60 divided by 255. Oh no, what have you done? 60 divided by 255 times. Right. Let's round it up. Cool. 111 divided by 255 times by 1023. Alright, let's keep the one rounded down. So it's 445 and 32 times 128. Oh yeah. Nice. So there's one color. Now we want a top color. So top color I'm thinking about. Oh, like one of them. Lovely. Lovely. Oh, thank you so much. Thank you for trying to be a hand. Yeah. Appreciate the effort. I got one which was kind of close enough. Oh, you've been using C-Line. Right, you're learning Neovim. Making my config. I can see. Yeah. Yeah, that's the thing, is you have to make that stupid config in Neovim, and then you like plaster in someone else's. Like I had one, right? I used Vim before, and I came to NeoVim because I wanted to see what all the, all the, I'm a, I'm like borderline Gen Z / borderline millennial, right? So here's me like using NeoVim, sorry, using Vim, but then my Gen Z side is like, I should try out NeoVim and see what it's all about. So I go and look at it. It was all right. I didn't see benefits, too many of the benefits they brought for C programming, but there's some cool stuff in there. But it just kept adding lots and lots of stuff. But still, it evolved into this sort of like maintaining a big old Vim script, or maybe like a Lua script now, and getting that thing together. Whereas if you just use Helix, it's just set up right out of the box. And it got to a point where I updated some of the plugins, and I had to have also updated my Vim scripts thing, and it kind of broke. Something broke. I don't quite remember exactly what happened, but there was some package manager errors, and you know, yeah, it was strange. So I was just like, you know what, that's it. Moving over to Helix. It's been awesome. Been awesome. It's the text that I've always kind of wanted. Right, let's do some more maths. Quick maths. Right, this is the top color. So this is a nice like lime green. So 166 divided by 255 times by 1023. Right, so 665. And the last one is 3. So that's basically times by 4, isn't it, at that point? Yeah, aren't we just timesing these numbers by 4? Is that all we've been doing the whole time? If we just think about it, is that all we've been doing? Is times them by 4? When I get to the end, I've just realized it's just a times by 4. Anyway. Right, the final one is a vein color. So the vein, right, it was, imagine like a vein going through the grass in the middle. We could just make that white. Or like a gray. Like kind of a bright gray thing. Make it 50% gray. I don't know why, but let's just do it. Now, there's a few more parameters. There's curviness, veininess, curviness, and glossiness. Love those guys. Oh, hang on a minute. Okay, so we're looking at, looking pretty well. So I understand. I heard some same thing from others as well. It seems like a pain to maintain. Yeah, it's a bit like using Arch Linux, right? Well, it is a bit like using Arch Linux. No, no, it's not. Um, yeah, it is. Yeah, it is precisely. It's like using Arch Linux. It's like you've just got to configure your system and then keep it going. No, it's not bomb color. Sorry, veininess. What a name. So it's going to have about 0.1 veininess. Maybe. 10% vein. Oh, we need to do a set. The next one would be veininess, curviness. So let's have one, all the curviness. That's what I want, super curviness. Then my final one would be glossiness. Let's make it super glossy. Let's make it look like whatever, right? Let's make it look that way. Cool, I'm happy with that. So that is the material done finally. It took a bit of time, but it's done. Next thing is vertex shader, then the scene shade. Do you use Helix inside WSL or is it good for Windows natively? So you just need to compile it, I think. So I think I compiled it. So you go on Helix's website, hang on a minute. I think it tells you that you don't have any pre-built binaries, so you have to basically download it and install it for Windows. But there is instructions for that. It's very simple. You just need to have Rust installed on your machine. And it runs natively inside CMD. You don't have to use Windows subsystem for Linux or anything like that. Yeah, build from source. This is it. Install in Helix, build from source. There's a Windows one on here somewhere. There you go. So I've just kind of kept mine not updated for a while because it just works fine. Yeah. Yeah, exactly. Don't have to use any, because if you use Windows subsystem for Linux, it's a virtual machine and it has some problems going across the boundaries sometimes. Get what those are all the time, but there we go. I think it's something to do with the disk. Right, so vertex shader. So grass VS. Here we go. So this is where the fun begins. So we're going to get a grass blade instance GPU and all right. So it would kind of be cool. Yeah, so let's go back to that thing. Yeah, so it's triangle strips. 1, 2, 3, 4, 5, 6. So effectively you want to define 2, 3. Yeah, so it's quite easy to do this, I think. You just take your vertex index, right? Even, it's like an odd even type of thing. Then if you got the last one, so your mod 2 or and 1 in that case would give you like the X side of things. Yeah, so you like float that. You times 2 take 1. So it's -1 or 1. So it's either left or right. And then your, so this will be known as position local space. So your Y would then just be GL vertex index. Divide by 2. Right, so I guess you just shift right by 1. That would be yeah, basically, right? So but then divided by how many segments? There's 6, right? So 1, 2, 3, 4, 5, 6, 7. No, 7. Wait. 0, 1, 2, 3, 4, 5, 6, 7. Yeah, there's 7 places it can land. So no, but 6 would be 1. Yes, just divide by 6. So it's divided by the number of segments, which is stored inside the this grass blade segments cap. Nice. Maybe it's called should be called a count. Anyway, so now if you happen to have the last segment, so if your segment is yes, if your vertex index is actually 15, then you actually just want to keep it on 0. Right, so really you should do it the other way around. So you do if it's not equal to 15, do that. Else do 0. Yeah. Cool. So that'll get you your position in local space. That'll do triangle strip basically up there. Nice. And the next thing you need to do now is transition. So you transition into world space. So we don't have a matrix because the matrix would be too big and it's horrible, blah, blah, blah. So we want to handle this correctly. So we first start off with probably a scale, then a rotate. You take your position local space and you slap it into world space. Boom. Then you say position world space times equal instance dot scale. Now you're scaling it the XY. So because it's go across the X on the Y. Now we need to rotate. So we're rotating around the Y axis. So how do you do that again? You could build a rotation matrix and do it that way, but there must be a, I forget. Hang on a minute. Is it just sine and cosine, but then that just gets you the, no, that gets you the angle. Yes, arc, is it arc cosine? I forget. Just quickly figure it out. So how do we rotate 3D vector with gradient with a float radiance value in GLSL. No matrix. Alright, well, what is it again? Yeah, build a matrix, man. Come on. I want to build a matrix. Maybe it is just a matrix. Yeah, maybe you have to use a matrix then. Hang on a minute, what's this? You don't need to rotate in one axis like this. You can use the 2D. Yeah, this is what I want, right? So you got your V. Yeah. Just got to get these the right way around and the positive negatives. Mm-hmm. So, for us then, it will be something like pos world space equal vec3. So we need to have sine, so S and C, I guess you call it, the sine instance rotation Y. There we go. So it's pre-computed. So that will be pos world space dot x times sine or cosine. Take pos world space dot y times sine. And it's just the other way around. So that's around the z. Yeah, so we're doing around the y. So it's that would then just be oh, it'd be z, sorry. Yes, then it'd be sine and then cosine. And I think you do a plus. Yeah, so sine, cosine. Yeah. We might switch these around if it does it the wrong way around, but we'll see. Right, so that's now moved into world space finally. So this is your world space transform. Now you're in the view space. You need a triangle ID as well. And then you need to be able to compute a instance ref. So I think with this instance ref thing, it's built for, what it's really built for is a mesh system, right? Where each triangle can pack specific data that you need to recompute and blah, 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 blah. But yeah, I don't know what we need until we go to the other end probably, but we need something different. And we need to probably have like a pixel type so it can store, hey, this is a mesh. Hey, this is a grass blade. Obviously, they're both meshes, but, it's a different system effectively doing the rendering. But yeah, so we need to pull the data from a different place. So let's go into the scene shade. So, the way the game works is renders into layer buffer, and inside the render layer buffer fragment shader, we just use this pixel interlocked thing. So locks a pixel, you bring in the 4 depths and 4 objects, and effectively do a sorted insert into each of the 4 channels. Sorry, sort insert of this pixel into one of the 4 channels, R being the closest and alpha being the furthest away. So it's just 4 layers. We can do order independent transparency this way. So we do lose the fact that the depth buffer doesn't run, right? But this does the depth buffer in software. But yeah. But it's cool because you get order independent transparency and other things. Now, scene shade just reads this in, and it takes the object and decodes it, reconstructs it the other side. So we go over all the layers in the layer buffer. We pull out the instance index and triangle index, and we haven't really got a proper mesh system yet. So we basically grab the instance and start ray tracing into it. So yeah, we need to like sort stuff out. So we need some kind of like surface position, tangent by tangent thing. Okay. Yeah, we'd need that actually. So we can transform back into the local space of the object. That's true. Uh, sorry, into the material space. Yeah. Yeah, if you want to use ray tracing hardware, if you will, or hardware, um, the API in Vulkan is like stupidly complicated and also kind of it's a black box. So like there's like a thing called like a shader binding table, and you basically have to manage offsets into that table. And the offsets come from like a few different places, and there's some formula that basically happens behind the scenes to calculate the perfect index to launch a specific shader. Um, you have to build like bounding volume. Sorry, yeah, bounding volume hierarchies using their APIs and stuff. Like, it's doing that acceleration structure API is a lot more simple, I think, than making a BVH yourself. But like, yeah, it's complicated. Um, it's a complicated API. Um, but yeah. So I try to avoid it basically if I do any ray tracing. Um, well, I've avoided it in this project. I just do ray tracing in software, but I've not got any global illumination, so that's the one where it's like, if you do GI, then typically you need some kind of acceleration structure and ray tracing. Kind of. You don't always need it. There's other ways, but yeah. Yeah, I don't actually like it in games. Yeah, it does come at quite a cost. You know, they're trying to optimize a problem which basically requires fetching a bunch of memory from many different locations in memory, and the the cores on the shaders will be will be diverging quite a lot as well. Like, it's not really a good solution for GPUs to be solving in particular, but they try and make it work. They've got some like shader table, some shader reordering thing. Sorry, ray reordering hardware and stuff like this to sort of make it work better. But yeah. Like, if you have an SDF of the world, it's much better that way for lots of things. Um, but yeah, so how are we gonna get the grass? I think the idea was if Moore's law continued, the idea of searching for a primitive per pixel versus rasterizing would makes more sense in future, but it's sort of stalled. Yeah, they kind of use more of the space now for like, or they put those tensor cores in there now rather than just put more GPU cores, you know. That'd have been cool. All sorts of mhm. Yeah, I guess you would have. Yeah, there's lots of tricks you would typically do. You know, if you could bake it, you would basically do the ray tracing offline, right? Um, yeah, there's plenty of other things as well. You could just rasterize different camera views. That's what games would do in the past, right? It's just, r- yeah, just do like small probes that rasterize like a cube map, basically. So there was ways around it. Mm. How do you back into the local space of the... Because you've moved it now, like you've animated it. This is what I'm thinking. You've animated it. So you've got a grass blade. You want to get it into this space where it's just a little straight piece of grass. But what you got is one of these. Bum, bum, bum. So given the fact that you got a bunch of triangles, given the fact you've got a bunch of triangles and things, how do you... Yes, how do you sort of like get that back into the local space? You know, each triangle... So the instance could store... Yeah, no, it's actually really easy, I think. You would store the T. Would you store the T? You can definitely store the Y. That's what I meant to say. T up the thing. But you can't necessarily store the X because you're in sort of vertex space at that point. Well, yes, in the pixel that you render these triangles into, you could use some of the bits, quite literally store some of this information. Your riches went hand in hand also with expectation of using AR denoising. Oh, great. You're not a fan of denoising. Yeah. You know, sorry, I'm not a fan of temporal denoising. I don't mind the idea of like a blur, you know, just doing a blur over the pixels and to make up for the fact there's missing pixels. But temporal stuff, man. Yeah, I think it's just temporal. I'm not a fan of temporal. Like there are like one or two like temporal things I would use. Like I would use a occlusion buffer, which is kind of temporal, right? Using the previous frame depth and reproject it or something like that, or use it and do a couple layers of rendering, but basically. But yeah, I wouldn't do anything more than that, I think. um, yeah, temporal stuff, man. Not a fan. But yeah, we got to find a way to basically map back into material space. That's the basic problem we've got to solve. I'm not sure how we'll do it. The meshes will basically have a UV, right? So we could, like, the dumb and stupid way would be allocate all the vertices, and when you do your vertex buffer or something like that, or make your instances, you make a vertex buffer with all of the stuff you need, such that in the scene shade you basically just visit the vertex buffer, do the 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 barycentric interpolation, and voila. But that is memory intensive and all this. If we could store some of it in the pixel, that could also help. Um, or if we don't need it, or if we could reconstruct it without that information, that would also be a big help as well. But yeah, we just got to find how to do it. Yeah, temporal, temporal artifacts when things move too much. Yeah, and all games I like move heavily. Yep. Yeah, like if you play like an FPS or something like that, or like a driving game. Mm. Yeah. Right, I think that puts us in a reasonable place. We got most of it. We're literally on the final stretch now. When this code and the vertex shader is basically done, isn't it? Yeah, it's mostly done. I'm just got to figure out how to emit this triangle instance reference thing, in which we need to figure out what data we need the other side. But yeah, once we've got these two things plugged in, should just work. We should see on the plane an 8x8 set of grass blades, and then we can try and get them animated in the wind and changing the size of them, and get them to bend in a particular direction and stuff like that. Um, yeah, and we can just slowly progress from there basically, and get a field of grass, see how that looks, what the performance is like, and try and solve some of the problems where we make the grass look a little bit more natural. And yeah, move on from there basically. Right, in the meantime, guys, there's a Discord if you can come and chat. There's a timeline down below. Next stream is Tuesday and Thursday, 7:30 p.m. GMT +1. There's one on a Friday at 2 p.m. as well. And thank you for everyone who's supporting the channel. Appreciate you all. You'll be able to get the code to run your own local machine. If you follow that link, it's a subscription basically, and also support the channel at the same time. Thank you for everyone who's supporting the channel. But yeah, I hope you all have a good start to your work week, and I'll hopefully see you all in a future stream. Yeah, I'm so tired right now. My brain is like half asleep. Okay, good night, guys. God bless you all. Thank you. Bye bye.